Alright, so this is on section 5.7, which is on confidence intervals with paired data. So now suppose you're given n pairs of data, x1, y1, x2, y2, all the way to xn, yn. And we want to investigate the difference between x and y. So we let di to be xi minus yi. Then we can construct a level 100 times 1 minus alpha % confidence interval for the population mean of D. So there are two cases. First case is when n is greater than 30, then we have the central limit theorem to protect us. So the interval is given by the formula, the sample mean plus minus z sub alpha over 2 times the sample standard deviation divided by the square root of n. But if the sample is not big enough, then we have to assume that D is normally distributed. Under this assumption, we can construct a confidence interval using the student's t distribution. So it will be the sample mean plus minus t with the degree of freedom n minus 1 alpha over 2 times the sample standard deviation divided by the square root of n. And here we're going to make the same note as in section 5.3. If we know the value of the population standard deviation, then we use population standard deviation instead of the sample standard deviation, and we use z instead of t. Alright, so let's do an example. So suppose you have a drug that's supposed to lower blood sugar level. And we ask for 8 volunteers, so there's 8 volunteers. And we measure their blood sugar level before and after taking the drug. The units are all in ml, mg, dl. But all we care about is how much the drug lowers the blood sugar. So the first thing we calculate is the difference, D. Let's do this real quick. 16, 10, 8, 7, 10, 11, 9, 12. And after calculating the D values, we can find the sample mean using a calculator. This is equal to 10.375. And the sample standard deviation is equal to 2.774. So a 95% confidence interval for the population mean of D is given by D bar plus minus T with degree of freedom a minus 1 and 0.025 times SD over square root of A. These two values were calculated above, and the value of T7, 0.025 can be found using a T table. So with plugging all these values, this is equal to the interval 10.375 plus minus 2.3191. So this means we are 95% confident that on average this drug lowers blood sugar level by amount in this interval. Let's include the unit. So technically, this section contains not much new information. You either use z if n is greater than 30, or you use t when n is less than 30, and you assume the pair is normally distributed. Alright, so that's it for section 5.7.